We're going to be solving quadratic equations. But to start with, here's a linear equation, and I just want to remind you how to solve that. And we already know the answer is -3. So how did you do that? Subtract 9 from both sides. (3x equals -9). And then divide by 3. X equals -9 divided by 3, which is -3. So you should be pretty good at solving those simple linear equations now. But if you think of what a quadratic equation would look like, something like x squared plus 2x plus 1 equals 0, we can't solve it in the same way. Because you can't isolate the x here. You can subtract 1 on both sides, but then you have this x squared and x, which are not the same, they can't combine. You could isolate the x squared or you could isolate the x, but you can't isolate them both. And so we need a different strategy for solving quadratic equations. And the strategy I'm going to show you today is the easiest one. It's a graphical method of solving. We're going to have one method of solving graphically and then 2, possibly 3 methods of solving algebraically. But I want to go back to this question, 3x plus 9 equals 0. And here's how you solve it algebraically. We already did that. But if you wanted to solve it graphically, do you remember how to do that? Because you did learn it in grade 10, but probably didn't spend a lot of time on it. No? So what you need to do if you want to solve that by graphing, and this is a really good skill to have if you have a graphing calculator, because this is actually going to allow you to solve any type of equation you could imagine. Anytime a teacher gives you an equation to solve and doesn't tell you to do it algebraically, you could solve graphically. So here's the strategy. You make the equation equal to 0, which this one already is, and then you graph the related function. The related function is the same, but with a y in the place of 0. So we're going to take that equation and change it into this function, y equals 3x plus 9, and then graph that. When I graph it, it looks like this. And the answer is just the x value when y equals 0, because we replaced the 0 with a y, we're looking for what's the x value when y equals 0. And the answer is -3. It's right there. It's the x-intercept of the graph. So taking a look at this quadratic, we want to solve it. We can't solve we can't solve algebraically yet. So your only option is to solve it graphically. We need to look at what's the related function. So what function am I going to graph on my calculator to be able to find the solutions? Y is equal to 2x squared plus 2x minus 12. That's the related function. It's just replacing the 0 with y. If you don't have your calculator out already, get your calculator out and graph that. Once you make your graph of the related function, y equals 2x squared plus 2x minus 12, here it is. You want to find the x-intercepts. So on the TI graphing calculator, second trace, 0, left bound, right bound, find those values. Here they are. These are the two x-intercepts, -3, 0, and 2, 0. And what that means is that the solution to this equation that we were originally given is x equals -3 or x equals 2. Both of those values satisfy the equation. How could we check to see that they actually do satisfy the equation?
By substituting x with them.
Right, substitute them in for x. So I could do 2 times -3 squared plus 2 times -3 minus 12, and that should equal 0. So that's 18, 0. So 0 equals 0. So that one works. And then you could test the other one by filling in 2 And that gives you a 12 minus 12, 0 equals 0 again. So both of those numbers satisfy that equation. Both of them, when you fill them in, give you 0. This part down here, you don't necessarily have to do. You don't have to write it out, but you should be doing it. Anytime that you solve an equation, you should be checking to see if it's right. I'm never going to solve an equation and not do a check, either in my head or on my calculator or something. It's not often that you'll see me write it down like this, but unless it's a really complex equation. But I'll at least do that on my calculator or something so that you know that you're right. So here's the next one we're going to solve. This one looks a little bit different. 2x squared plus x equals negative 2. What do you have to do to this one first, do you think? Add 2 to both sides. You need to, it has to be equal to 0 for the second trace 0 thing to work. It has to be equal to 0 for the x-intercepts to be the solution. So here we're going to go plus 2 on both sides. And then we'll have 2x squared plus x plus 2 equals 0. The related function that you're going to graph then is y equals 2x squared plus x plus 2. But you can't figure that out until you make the equation equal to 0. Did you get a graph that looks like this?
Yes.
That poses a problem, doesn't it? So the question was to solve that equation, 2x squared plus x equals negative 2, and we get this graph. What does that mean? What is the solution? What is x equal to? 0 would be if the graph actually went through the origin, like that. That would have you a solution of 0. So the solution of 0 would imply that the graph goes through the point 0, 0, and it doesn't. So the question is, what value of x could you fill in here to 2x squared plus x equals negative 2 that would satisfy that equation? That would make, so how can you get the left side to equal negative 2? And the answer is, you can't. So the answer is not 0. The answer is, there is no solution. You will get questions like that when you're dealing with quadratics. You probably haven't seen that before, because when you're dealing with linear functions, you won't get a no solution unless it's a horizontal line. But with quadratics, you do sometimes get no solution. If it doesn't cross the x-axis, then there's no solution, and that's what you have to write, no solution. So when you graph the related function here, which is y equals 100 plus 15x minus x squared, you end up with a graph like this, which you had to zoom out a bit to actually see on your calculator. But you can find the x-intercepts of negative 5 and 20. You still need to write an answer. What's the answer to this? What's the answer? X equals negative 5 or x equals 20. That's the answer. So for this one, looks like here I actually did the negative graph where I subtracted x squared. So I did 0 equals 6x minus 9 minus x squared, and then graph the related function, so y equals this. And I end up, this one only has one solution. So the answer here is x equals 3. So we've actually seen 3 different possibilities for types of solutions. Some of them have 2 x-intercepts, which means 2 solutions. One of them had just one solution, and one of them had no solutions. And those are the three possibilities when you're solving a quadratic, whether you're solving graphically or algebraically or whatever. You could get sometimes two solutions. Most often you'll probably get two solutions, but sometimes you'll get one and sometimes you'll get none. I have one more here that I want you to try, which is this one, x squared plus 4.5x plus 5 equals 0. So this one, when you graph that related function, at first glance it looks like there's only one x-intercept, but when you zoom in on where the x-intercepts are, you can see that there are actually two. So just be careful of that when you're solving graphically. We have x equals negative 2.5 or x equals negative 2, and both of those values will satisfy that equation.